Next topic in this chapter is hydrogen bond. Hydrogen bond, this is the last topic in this chapter, and this is also one of the very important topic in this chapter. Hydrogen bond. See, what is the definition? The weak electrostatic force. Electrostatic force means attractions between positive charge and negative charge. That is electrostatic force. Then why it is weak electrostatic? Because that attraction forces exist between partially positive charge and partially negative charge, not completely positive charge and not completely negative charge. That is why they are telling like that, weak electrostatic force of attraction between partially positively charged hydrogen atom and highly electronegative atoms such as either fluorine or oxygen or nitrogen only, between two same or different molecules. Between two same or different molecules is called hydrogen bond. It is represented by dotted lines. See, I repeat this point, listen carefully. This is positive charge, this is negative charge. Between positive charge species and negative charge species, attractions are present. These attractions are called strong electrostatic force of attractions. But between partially positive charge, this delta indicates partially. Between partially negative charge, attractions are present. Those attractions are called weak electrostatic force of attractions. That means this is weak bond. Though because of those attractions, one bond will form. That bond is called what? Hydrogen bond. That should be formed between two same or different molecules. That partial positive charge exhibited by should be exhibited by hydrogen, and that partially negative charge should be exhibited by either fluorine or oxygen or nitrogen. This partial positive charge should be exhibited by which one? Hydrogen only, and this partial negative charge should be exhibited by either fluorine or oxygen or nitrogen, because these are high electronegative atoms. Then that bond is called what? Hydrogen bond. It is represented by dotted lines. Next, it is weaker than covalent bond and stronger than van der Waals forces. Van der Waals forces are very weak forces, but compared to that it is somehow strong, but compared to covalent bond it is weaker. Next, conditions to form hydrogen atom. This is important. What is the condition? The hydrogen atom should be attached to either nitrogen or oxygen or fluorine. That is NH bond or OH bond or HF bond should be present in molecule. Then only that molecule exhibit hydrogen bond. This is very important point. To exhibit hydrogen bond, that hydrogen should be attached to either nitrogen or oxygen or fluorine. That means that molecule should contain either NH bond or OH bond or HF bond. Exception: chlorine atom rarely involves hydrogen bond. Rare cases. In rare cases only chlorine atom involves. Next, no need to remember this point. Next point. This point no need to remember. Next point, the electronegative atoms should be in small size. That means nitrogen, oxygen, these are small size. As the electronegativity increases, strength of the hydrogen bond also increases. The electronegativity increases, strength of the hydrogen bond also increases. Here first point is very important. The hydrogen atom should be attached to either nitrogen or oxygen or fluorine. Then only that molecule exhibit hydrogen bond. See, I will show the example, then you will get clear idea. For example, CH3OH. In this case, hydrogen attached to oxygen, so that what happens? The molecule can exhibit a hydrogen bond like this. This indicates what? partial negative charge of oxygen and a partial positive charge of hydrogen. So this CH3OH can exhibit a hydrogen bond. What is the reason? This hydrogen attached with oxygen. Because of more electronegativity of oxygen, it gains electrons from hydrogen, so it gains partial negative charge, it gains partial positive charge. Now between oxygen and hydrogen already covalent bond is present. This is not a hydrogen bond. Then how can we say that this molecule forms hydrogen bond? This molecule forms hydrogen bond with the same type of this molecule, with the same type of this molecule. In CH3OH, this is liquid, this is present in liquid state. In that liquid state, so many such molecules are present. Between those molecules, attractions are present due to hydrogen bond. Those attractions like this. This is one more of CH3OH molecule. Here also negative charge, positive charge. Now attractions present between this hydrogen and oxygen, and this oxygen and hydrogen. These are hydrogen bonds. That is the point. Already here covalent bond is present between oxygen and hydrogen. This is covalent bond, not hydrogen bond. But due to high electronegativity of oxygen compared to hydrogen, this oxygen acquires partial negative charge. This negative oxygen, partial negative oxygen can form hydrogen bond with the same type of, same molecule, same type of another molecule. And here also this hydrogen, this partial positive charge of hydrogen can form hydrogen bond with the same another molecule of oxygen atom. Like that hydrogen bond is formed. Now one more example, then you get clear idea. NH3. In NH3, three hydrogens attached nitrogen. NH bond is present. If NH bond or OH bond, hydrogen should attach with either nitrogen or oxygen or fluorine, definitely that molecule exhibit hydrogen bond. Now NH3 molecule also exhibit hydrogen bond. Why? Because hydrogen attached nitrogen. Compared to hydrogen, nitrogen having more electronegativity, so that the hydrogens exhibit partial positive charge, but nitrogen exhibit negative charge. Here the point is what? This hydrogen bond is not present between these nitrogen and hydrogen. This is formed between nitrogen of one ammonia molecule and hydrogen atoms of another ammonia molecule. Another ammonia molecule is like this. Here also positive charges and negative charges are present. Now attractions are present between one nitrogen atom of ammonia and a hydrogen atom of another ammonia. Then the attractions are present. This bond is called hydrogen bond. Here this bond is called hydrogen bond. So to exhibit hydrogen bond, what is the condition? Hydrogen should be attached with either nitrogen or oxygen or fluorine. Next point. This hydrogen bond is two types. They are intermolecular hydrogen bond and intramolecular hydrogen bond. Intermolecular and intramolecular. Simple definitions. Intermolecular means if the hydrogen bond is formed between two same or different molecules, it is called intermolecular. Inter means between two same or different. That is called intermolecular. For example, take water. In water, there are so many water molecules are present. Those are associated by hydrogen bond. This is water molecule. This is water molecule. If you observe this structure, then you get clear idea of hydrogen bond. See here, this oxygen expires negative charge. This is one water molecule. This is another water molecule. This is another water molecule. So between all molecules, which forces are present? Hydrogen bond forces. Why? Because oxygen acquires negative charge. Hydrogen acquires positive charge. Between oxygen atom of one water molecule and hydrogen atom of another water molecule, hydrogen bond is formed. This dot indicates what? Hydrogen bond. Here also hydrogen bond is formed. The molecule which exhibit hydrogen bond with water is more soluble. This is very important point. The molecule which exhibit hydrogen bond, that means if any molecule forms hydrogen bond with water, then that molecule having more solubility. Next point, intramolecular hydrogen bond. intramolecular hydrogen bond. Intra means within, means same. If hydrogen bond is formed within the molecule, that means within same molecule, then that is called intramolecular hydrogen bond. Example, see, this is organic compound. In this organic compound, benzene ring is present. In that benzene ring, one position occupied by CHO group and one position occupied by OH group. Here compared to carbon, oxygen having more electronegativity, so that it acquires negative charge. Here compared to oxygen, hydrogen having less electronegativity, so that it acquires positive charge. These two groups present in one benzene ring. That means all this is one molecule, but here attractions are present between this oxygen atom and hydrogen atom. This oxygen and hydrogen atom. These attractions are called what? Hydrogen bond attractions. Weak electrostatic force of attractions. The molecule which exhibit intramolecular hydrogen bond is insoluble in water, because already here hydrogen bond is formed between oxygen and hydrogen. So when this molecule is present in water, it cannot form further hydrogen bond, because already here hydrogen bond is formed, so it cannot form further bond with water. Next point, there are some more points. Next point, the molecules which exhibit intermolecular hydrogen bond have high boiling point and low volatile nature. This is also very, very important point. The molecules which exhibit intermolecular hydrogen bond have high boiling point. Why high boiling point? What is boiling point? The temperature at which liquid is converted into vapor is called boiling point. That means we have to break the bonds. But intermolecular hydrogen bond means hydrogen bond is formed between two same or different molecules. For that purpose, for boiling point purpose, we have to break all the bonds. It requires more energy. So what is the point here? The molecules which exhibit intermolecular hydrogen bond have a high boiling point and a low volatility nature. Low volatility means evaporating nature. If the substance readily undergo evaporation, then that substance is said to be more volatility. Suppose take petrol. When you take petrol on hand, immediately within fraction of seconds it undergoes evaporation. That means petrol having more volatility and less boiling point. Between volatility and boiling point, inversely relation is there. So what is volatility? Volatility means if a substance readily undergo evaporation, that is called volatility. So all intermolecular hydrogen bond molecules having less volatility, because they do not undergo evaporation, because they have more boiling point. It needs more energy to break bonds. Next, the molecules which exhibit intramolecular hydrogen bond have low boiling point and high volatility nature. Intra means what? Hydrogen bond is formed within the molecule. That means hydrogen bond is formed in one molecule only. So it is somehow easy to break the bond, because that hydrogen bond is not formed between two molecules. It is formed between two atoms of same molecule. That means that bond strength is somehow less. So they are having low boiling point and high volatility nature. That means they readily undergo evaporation. Next, boiling point depends on two factors. They are molecular weight and hydrogen bond. These are that means if molecular weight increases, boiling point also increases. If a molecule exhibits hydrogen bond, then also boiling point increases. That is the meaning of that point. Next, some more points are there regarding this one. Ortho compounds. Ortho means on benzene ring, if two groups present on adjacent position, that is called ortho. If between two groups one gap is present, that is meta. If two groups present on opposite position, that is para. I repeat those points, listen carefully. If two groups on benzene ring present at adjacent positions, that is ortho. If between two groups one gap is present, this is one gap, that is meta. If two groups are present in opposite position on benzene ring, that is para. So what is the point here? Ortho compounds. This is ortho, this is meta, this is para. Ortho compounds forms intramolecular hydrogen bond, whereas meta and para forms intermolecular hydrogen bond. Why are the forms intra? Because these two groups are adjacent each at adjacent positions, so they can form intramolecular. That means attraction. They form hydrogen bond between this hydrogen and oxygen. But here one gap is present, so it cannot form hydrogen bond. Already hydrogen bond is weak. Here gap is present. That means distance is more, so it cannot form intra. Here distance is very far, so it cannot form intramolecular hydrogen bond. That means between this oxygen and between this hydrogen and oxygen, there is no chance of hydrogen bond. In case of meta and para, no intermolecular hydrogen bond. But ortho, in case of ortho, intermolecular hydrogen bond is present. Why? Because these two groups are present at adjacent positions. Next, meta and para-nitro compounds can form intermolecular hydrogen bond. That means if you take another meta-nitrophenol, between those two compounds, hydrogen bond is formed. If you take one more para-nitrophenol, between this one and that compound, hydrogen bond is formed. Next, any liquid forms hydrogen bond with other molecule. Then it is called associated liquid. Example, water is associated liquid because in water there are so many water molecules. Between those water molecules hydrogen bonds are present. That means one water molecule forms hydrogen bond with other molecule. That means water is associated liquid. Next, any liquid does not form hydrogen bond with other molecule, then it is called normal liquid. For example, benzene. In case of benzene, what is the molecular formula? C6H6. There is no hydrogen atom attached with nitrogen or oxygen or fluorine, so benzene cannot form hydrogen bond. But benzene is a liquid, so it is a normal liquid. Why it is normal liquid? Because between benzene molecules no hydrogen bond is present. So this is all about hydrogen bond. This is also one of the very important topic. You have to remember this topic. If you have any doubt, we will discuss those queries in live class. And moreover, you have to remember this topic because some applications will come in 12th class regarding this topic. Thank you. This is the end of chemical bonding chapter.